Welcome. It's the time of the digits. Math in the PM. Welcome aboard. Shanelka here as the smooth stylings of Rami and the Raiders here. Anyways, with the hit single Math in the PM. Hot dog, we got some out of sight stuff, square roots, and now perfect squares. Let's get down to business here. Okay, so perfect squares are things like, well, I have to squeeze you on these things. Let's see, you guys write it down, we do it. We doing it. So perfect square examples of perfect. Okay, so paper up. All right. I don't want you. I know you know a lot of this stuff, but I don't want you to miss it. Okay. I'm gonna write down a couple others here, and I think you already heard the answer. You're correct. That one. Maybe you know this one. It's a related problem. And see, hopefully you know this one. Doing the square root of three different perfect squares. Okay? I'll give it a second here, and then we'll jot down some answers, please. Questions in the world. So the first one, Rami, I think I heard you say the answer, right? Well, good heavens, tell me it's first one. It's a rhyme. Yeah. Decimal sound, 0.7. Make that decimal strong enough that I can read it though. And this, you can square root of the top, square root of the bottom. These are perfect squares, 25 and 16, right? So 5 out of 4. The answer here. So all three of those under the square root signs were examples of perfect squares. So perfect squares, a little bit of note. You're going to copy this. Perfect squares can be given as a fraction. Terminating decimal. having this fraction, terminating decimal, 0.49, that terminates that end, so it doesn't go through. Or a repeating decimal that could be given as a fraction. I give the example of 0.111111. So I put a line over the 111 just to show that it goes on. That's the same as 1 out of 9. You know that 1 square root, 9 square root. So yeah, that's a perfect square. It's hard to see perfect squares when they're on a repeating decimal. You can see them in the fractions. But now, non-perfect squares. When I see a perfect square, I think there it is here. So, I see 25 and I'm like, I don't deserve this perfect square. Anyway, but when I see something else, non-perfect. Non-perfect. What am I meaning by a non-perfect square? Example is pretty well any other number. So 48. Oh, that's not. And if I use a calculator, yeah, I showed you guys that button. You don't get 6. Like I know this is just a little bit less than 7. It's 49 is square root of 7. This comes up to be 6.9. 928. So, it goes on from there, but it doesn't repeat. Irrational number. Non-perfect. Because the decimal doesn't terminate. When I say terminate, I mean it ends or repeats. In order to do this section well, we really have to have our perfect squares under memorized. And I told you guys, I'm going to just go through what that is down. The perfect squares. Looking at. So in the margin, whether you have it on the left side of the paper or the right side, you should be able to rattle these off fairly fast. I'm going to do the first 10. So 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 1. And then 10 squared is 100. Those are all the perfect squares, right? 10 for 100 and less. Okay. Now I'm going to keep this in mind when I try some problems. We're going to estimate without a calculator. Okay, I'm just kind of waiting for people to be caught up. Let's estimate using estimate square roots. We need benchmarks. We're going to show it on a number line. And you're going to do that on evaluations with me. So practice. We'll go 27. Well, I'm going to put in the other color what you're thinking. Think about two perfect squares that surround. So, yes. 25 and 36. Exactly. Ah, so 27 between those two perfect squares, right? 25 and 36, and it is closer to the 25. So I'm going to use a number line, and you're going to have to know how to do this. I'm going to quickly draw a small portion of a number. 25. Root 36. We know that the root of 36 is 6, root of 25 is 5. That's what we're trying to estimate. So I'm going to guess that my root 27 is closer to the 25 than it is to the 36. So I know it's probably not going to be 5.5 or bigger. It's close. I don't know. What would you guess? 5.1, 5.2, 5.2? What do you think? Okay, I'm going to go with one decimal. So I'll go with 5.2 based on. So underneath here, this is what we're going to say here. Square root 27 is, and I'm going to put a wavy equal sign. Wavy equal sign means apart. It's about 5.2. I showed using benchmarks why it would be. The wavy equal sign means apart. That's right. So if you're given just a whole number, that's one zero. Goodness gracious. Another example. Now, what about fractions? That's 20 estimates 10 over 35. Square root for a fraction. Well, here I'm looking for, and I'm not going to be confusing and have something exactly in the middle. What perfect square is close to 10? Closest one to 10. On the list in blue? 9. That's approximately the same as saying, well, it's the square root of 9. 35, that's approximately close to perfect square, 36. Do this. Once you have that estimation, well, that means that approximation is approximately, well, the square root of the top 3, square root of the bottom 6, which is about half. 10 out of 35 square root is about half. you're estimating with fractions, find the closest ones and make a new fraction. When you're estimating with just whole numbers like root 27, do a quick number line and show which one it's closer to and then make a decimal estimate. Are you good with that? I'm going to pause the video to just enter attendance. The other thing we're going to do is a review of something you've seen before, Pythagorean theorem. With this I'm going to draw a triangle. Make it a little like that. It has to be a right triangle. You can't just do this with any old triangle. Label the sides A and B for the ones that are attached to the 90 degrees. They're called blades. The hypotenuse is across. There's always the C. What's that? Okay. C is always across from 90 degrees, and it's called the hypotenuse. There's four. What's that? The letter C or which one? Draw very similar to this. Have a corner, 90 degrees. If you have to draw it precisely like this, it could be a little shorter like I drew. It could be a little taller. That, as long as it has a 90-degree corner. Okay? That's what I'm, as far as note-wise, that's what you have to have. Yeah, and I would stop mid-sentence. C is always across from 90 degrees. It is called the hypotenuse. Okay? And the formula that we use for this, C squared equals B squared plus B squared. We'll do two examples. I'll just draw them from scratch. A little bit. I'll do the left green one first. Find the length bar. Length bar. And I'll label it R. Meters and 6 point. Leave space on the right hand side. Split the kind of page in half. We'll do a right hand one now. So here's Here's what I think when I see this. Pardon me. What I've labeled in green is not A, B, or C. I have a letter R and then two numbers. So I've got to think, what's like my C? Which one's across? It's the letter R. It's the one. It's the longest of them. Actually, I should label this 90 degrees with a little square in it. So my R is like my C squared. So I'm using this, but I have different letters. So I'm going to put the letter R. Now my A squared and B squared, I'm thinking they're like the 1.5 and the 6. And I don't care if I put 6.5 first or 1. I'm going to leave the centimeters out or the meters out until the end. We have calculators, and I want you to get them out there. You're always welcome to. Yeah. Oh, what's my calculator today? Okay, so let's use that one. What do you have for your Not quite. But we'll get there. I'll show you why, because there's another step to do in my kitchen. Think about it. Okay, but I'm not going to go that fast. I'm going to go through step by step. I know a few of you can do this, but you remember. 1.5 squared. Use your calculator to do that. And we're working down. And this is something you're getting used to doing in algebra. Root 1, 2, 5, 2 1/4. Then, see how I replaced it directly underneath 1.5 squared? I'm going working down. Now, and then the plus sign I put there. The 6.5 squared, I'm going to put it in my calculator. There you go. I get 42.25. Now, I'm going to slow us down a little bit here, make sure everybody's following that step. Are we? I'm working down. I'm doing nothing to the R squared. But I am adding 2.25 to 42.25. I'm getting 44.5. This doesn't solve us for the hypothesis, though. This is R squared. We got to think about what we learned last week. What's the opposite of squaring on your calculator or in math? Square root button. Yeah. So what I'm going to do is I'm thinking, if I do the square root of the R squared, it's just going to be plain old R. That means I have to do the square root of 44.5. So that's my next step. That's a disappearing ink on purpose. We're going to write down the letter R equals 44 and a half under a square root symbol. You're going to use your calculator. And then, I heard 44 and a half already, but that was squared. You undo the square you get, and use your calculator. I want people to do this. So they want to know you can use a square root. I'm going to pause it because different brands are a little different. Sometimes you shift. Some don't need it. Second function on other brands. No, I mentioned 6.67. I'm going to round to one decimal place. Properly rounded 6.7. And that's now I'm saying, oh yeah, right. These were meters at the start, so the answer will be. Okay? That's fairly easy. We did ones like that in grade 8 probably. Let's do another example though. This one in blue. This one will be more algebra. Yeah, I'm going to put that on one of the legs. 4.1. And then 2.5. I'm going to use the same formula, but the letters don't match that. Oh. Which one of those, M 2.5, 4.1, which one of those is like the C squared, the hypotenuse, across from the 90 degrees? the 4.1 this time? A squared, I'm going to say, is sort of like the M. We're going to put M squared. That's 3.5. Like B. That's squared. Why should people jot this down and then want to work straight down? You put 4.1 in your calculator and square. I'll just wait for this. I'll try to do two things at once. Okay. Wait a minute. When I put 4.1 in my calculator, it's squared, so 4.1 times 4.1, I get 16.8. I'm leaving a bit of space here, and you'll see why in a second. M squared, I can't do anything. I'm just calling it M squared, but when I put 3.5 and squared in my calculator, I get 12.2. So I just worked straight down, replaced everything with reduced. Here's why I left the space there. I want to solve it. Maybe I'm going to just do it in the next line. Still a reason why I left the space. Here's why I left the space. I want to get the letter all by itself using addition or subtraction. M squared is on the right-hand side, but it's added plus like 12.25. What's the opposite of adding 12.25? Opposite operation is subtract. I subtract from the one side, I got to subtract from the other. 4. I'm going to say, well, minus 12.25. And I'm going to subtract it. This is why I left the space here. Okay. This is algebra. So on the left-hand side, I use a calculator and do the subtraction. I get 4.56. Like grade 9 stuff. These are grade 9. Big shout out to Ronnie and all the grade 9s. Big boys now. Oh, I would. On the right-hand side, though, the arithmetic is really easy because we designed it this way. So 12.25 minus 12.25, that zeroes out. And that's why we invented that subtraction. So I'm going to just put M squared. Now, the last time that something squared equals a number, we said take the square root of both sides, right? So that does the M. So square root of that. The letter M. Then I need a calculator to do this. Type square root. I'll give it a minute here and get some answers from people. Round it to 1 decimal spot. Hence position. Yeah, wrong. 2.1. So much fun. Get things done, son. 2.1. And that diagram, I had it centimeters. Centimeters is equal to side M. Okay. Now, you need to practice on it. I'm going to give you a chance to practice. I will help you then. Some people do, so I'm going to write down the assignment first, and then stop recording and help you. The assignment. And that's fine if you don't understand. That's my job to help you. Page 18. Number 4 ABC, 6 AB. I'll go with ABC. 7 ABC, 13 ABCD. That's it for the recording. Over and out, y'all. Want to sing a song again? Saying at the start.
A, B, C, 1, 2, 3.
More like that. A, B, C. Stop.